Somewhere in the vast, steaming interior of the Florida Everglades, a helicopter banks low over a carpet of sawgrass and open water. A technician leans out of the open door, reaching into a canvas bag, and begins releasing something into the air below. Not nets, not tranquilizer darts, dead mice. Hundreds of them, each one carrying a tiny cardboard streamer designed to snag in the branches of the tree canopy below. Each one stuffed with something that sounds, at first, almost laughably ordinary. The active ingredient in Tylenol. This is not a scene from a science fiction film. This is a real government-sanctioned experiment unfolding right now in one of the most ecologically sensitive landscapes in the entire Western Hemisphere. And the target of this operation is an animal that has turned the Everglades into its personal kingdom over the last 4 decades, the Burmese python. To understand why wildlife managers are seriously considering dropping millions of medicated mice from helicopters into a UNESCO World Heritage Site, you have to first understand just how completely and catastrophically the conventional approaches have failed. The crisis that never stops growing. The Burmese python arrived in Florida almost certainly through the exotic pet trade. In the 1980s and into the 1990s, hatchlings were sold cheaply at reptile expos and pet shops across the state. They were manageable at 2 feet. They became considerably less manageable at 12, 14, 16 feet and north of 100 pounds. Owners released them. Some escaped during Hurricane Andrew in 1992, when a breeding facility was destroyed. The snakes found the Everglades warm, wet, full of prey, essentially winterless, offered them everything Southeast Asia had given them and nothing of the natural predation pressure that kept their numbers in check back home. Since 2017 alone, professional hunters, state contractors, and participants in Florida's annual Python Challenge competition have removed more than 10,000 Burmese pythons from the wild. 10,000 snakes pulled out by hand, by trap, by dedicated professionals working year-round in brutal heat and difficult terrain. And the population has not declined. The reason is ruthlessly simple mathematics. A single female Burmese python can produce clutches of up to 100 eggs. The snakes are nearly impossible to detect in dense sawgrass. They do not behave like prey animals. They do not investigate traps out of curiosity. They are not drawn to conventional bait because a 16-foot snake that eats white-tailed deer whole has no interest in the kind of lure that works on a raccoon. State data has shown it takes an average of 12 collective labor hours across all agencies to locate and remove a single python. At that rate, the math never closes. Removal will never outpace reproduction. So researchers began asking a fundamentally different question. Not how do we hunt them more efficiently, but what if the food supply itself became the weapon? The island that lost its voice. The scientific foundation for what is now being tested in Florida was built not in Florida at all, but on a small island in the Western Pacific that endured a quieter, faster, and in some ways even more complete ecological catastrophe decades earlier. In 1952, a brown tree snake arrived on the island of Guam, concealed in military cargo. It was a modest animal by snake standards, roughly a meter long, mildly venomous, and initially so unremarkable that early wildlife surveys barely noted its presence. What nobody appreciated at the time was that Guam's bird populations had evolved in total isolation from ground predators. They nested low. They laid eggs in the open. They possessed no inherited fear of snakes because snakes had never, in their entire evolutionary history, posed a threat to them. The brown tree snake did not find an ecosystem. It found a fully stocked pantry with no security system whatsoever. Within decades, the forests of Guam went silent. 12 bird species ceased breeding on the island entirely. Several were driven to extinction in the wild. The snake population reached densities scientists still find difficult to describe without the numbers sounding invented. Estimates of up to 5,000 individual snakes per square mile of jungle in the most heavily infested areas. The economic damage from snakes climbing power lines and bridging electrical transformers reached into the millions of dollars annually. Cultural traditions tied to birds that had existed for thousands of years simply ended because the birds were gone. The response that eventually emerged from that catastrophe, developed and refined by researchers at the USDA's National Wildlife Research Center, was the approach now being studied for Florida. Scientists discovered that acetaminophen, the compound in common over-the-counter pain relievers, is catastrophically lethal to brown tree snakes. Their livers cannot process it. A relatively small dose causes complete liver failure. The delivery mechanism they developed was elegant in its simplicity. Place a lethal dose inside a dead mouse. Attach a cardboard streamer so the mouse catches in the tree canopy rather than falling to the ground, and drop them by helicopter into areas with documented snake activity. Field trials on Guam showed population reductions of up to 80% in treated areas from single operations. It worked in ways that years of conventional trapping never had. Why mice and why juveniles? When researchers began seriously examining whether the Guam model could be transferred to Florida, the first and most obvious obstacle was body size. An adult Burmese python measuring 16 feet and weighing over 150 pounds is not hunting mice. A dead rodent in a tree is biologically irrelevant to an animal whose regular diet includes white-tailed deer, large wading birds, and adult alligators. You cannot lure an apex predator of that scale with prey it stopped considering food years ago. But juvenile Burmese pythons are a completely different animal in almost every behavioral sense. In their first 1 to 2 years of life, young pythons are approximately the same body length as an adult brown tree snake. At that size, small rodents are exactly the appropriate prey. Crucially, juvenile pythons also climb in a way that massive adults do not. While full-grown individuals spend the majority of their time on the ground or in water, young pythons move actively through low vegetation, branches, and the canopy zone, precisely the vertical space where a streamer-equipped bait mouse would end up suspended. Researchers who have tracked juvenile pythons using radiotelemetry have documented this behavioral profile directly. Young snakes are explorers. They move constantly. They investigate their environment. They are actively hunting small prey in exactly the zone where aerial bait drops would place it. The entire biological logic of the mouse drop strategy, as applied to Florida, rests on this one fact. You are not trying to bait an adult. You are targeting the generation that hasn't become an adult yet. And that is where the strategy's deeper ambition becomes clear. The goal is not to reduce the current population of breeding adults, which is enormous and largely inaccessible. The goal is to prevent those adults from being replaced. A female Burmese python does not threaten the ecosystem's future if she never survives to reproductive age. Eliminate enough juveniles consistently across enough of a landscape, season after season, and eventually the adult population begins to age out without replacement. The strategy is not about the snakes alive today. It is about ensuring that far fewer snakes are alive a decade from now, what the Everglades is not. Here is where the story becomes genuinely uncomfortable, and where scientists who fully understand the urgency of the python problem still find themselves unable to offer an unqualified endorsement of the solution. The Everglades is not Guam in 2000. When the mouse drops began on Guam, the island's native bird populations had already been devastated. The collateral damage calculation was grim but relatively straightforward. The ecosystem was already broken, and the intervention was managing an ongoing catastrophe in a landscape already stripped of much of its biological complexity. The Florida Everglades currently supports approximately 350 bird species, 60 reptile species, 40 mammal species, and 50 species of fish. It is one of the most biologically intricate systems in North America, and acetaminophen does not restrict its effects to Burmese pythons. Raccoon and opossum populations in the Everglades have already collapsed by roughly 90% due to python predation. These are exactly the kinds of opportunistic scavengers and small mammal consumers that would readily eat a dead mouse found in low vegetation. A population already pushed to the edge by one invasive predator now faces a secondary chemical threat from the intervention designed to address that predator. The compounding of pressures on species already struggling is not a minor footnote in any honest risk assessment. It is a potentially decisive factor. Secondary poisoning extends the concern much further. An animal that consumes a poisoned mouse and survives may still carry acetaminophen residue in its tissues. An owl that catches that animal, a hawk that feeds it to nestlings, a larger predator that scavenges the carcass. Each link in that chain represents another exposure point. These chains run through every level of the Everglades food web simultaneously, and they are essentially impossible to monitor comprehensively once aerial dispersal begins at meaningful scale. The animal that changes everything. Of all the species whose presence in the Everglades complicates the mouse-drop equation, none changes the calculation more dramatically than the Florida panther. Fewer than 200 individuals are currently believed to exist in the wild. Their range has been compressed into the southwestern corner of Florida by a combination of habitat loss, highway mortality, and decades of population pressure. The territory where these animals survive and the territory where Burmese pythons have established themselves overlap almost completely. For felids, acetaminophen is not merely toxic. It is among the most dangerous compounds in existence. A cat's liver lacks the enzyme pathway that allows most mammals to process the compound safely. Even small doses cause the destruction of red blood cells, followed by liver failure. The dose that might cause temporary illness in a raccoon can kill a large cat outright. Florida panthers are apex predators that hunt deer and wild hogs. But apex predators are also opportunists. A dead mouse in low vegetation requires no energy expenditure, no risk, no hunting effort. It is the kind of effortless caloric opportunity that a large cat, particularly one moving through familiar territory at dusk, takes without hesitation. Panthers scavenge. They investigate novel scents. They move through precisely the terrain, the ecotone between sawgrass marsh and higher ground vegetation, where bait concentrations would be heaviest. Every serious risk assessment for the mouse drop strategy in Florida reaches the same conclusion regarding panthers. Deployment within or adjacent to active panther range carries an unacceptable probability of causing direct mortality in a population that is already, by any biological measure, teetering on the edge of non-viability. The problem is that panther range and python range are not two separate territories between which a buffer zone can be drawn. They are the same territory. The lessons nobody wants to learn. Australia's long experience with large-scale invasive species poisoning programs offers the most directly instructive parallel available to Florida wildlife managers. Australian researchers discovered decades ago that sodium fluoroacetate, a compound lethal to introduced European foxes and feral cats, was far less toxic to native Australian wildlife that had evolved alongside plants naturally producing it. They built continent-scale poisoning programs around this selective toxicity, and in measurable terms, those programs worked. Native marsupial populations recovered in regions where introduced predators were suppressed. The results were real and significant. But the results were not clean. Eagles died from consuming poison carcasses. Native bird species turned out to be more sensitive to the compound than initial assessments suggested. Monitor lizards ate poisoned animals and died. And within a relatively short time frame, some target populations began showing early signs of tolerance development. The poison that was introduced as a permanent solution began losing its effectiveness against the very animals it was designed to eliminate. The lesson Australia offers is not that large-scale intervention is wrong. The lesson is that no large-scale biological intervention in a complex ecosystem produces only the effects it was designed to produce. Collateral casualties are not statistical anomalies. They are structural features of the approach. The only question that matters is whether the damage inflicted on the target justifies the damage absorbed by everything else. And that question does not have a clean answer before the program begins. It only has an answer afterward, when some of the consequences are no longer reversible. What comes next? Florida is not without options beyond the mouse drop. Detection dogs trained to locate pythons by scent have demonstrated genuine promise in field conditions, finding animals that experienced human searchers walk past entirely. The technique of fitting captured females with radio transmitters and following them to breeding aggregations has produced removals that would never have been achieved through conventional patrol methods. Pheromone-based trapping systems, pathogen research targeting python-specific vulnerabilities, and theoretical genetic approaches modeled loosely on programs used against invasive insect species are all in various stages of investigation. None of them are ready. None of them are cheap. None of them can be deployed tomorrow at the scale the actual crisis demands. And none of them have the operational simplicity of a helicopter, a bag of mice, and a compound that costs almost nothing per dose. Marcus Reyes flew home after dropping 300 mice into the sawgrass on a Tuesday morning, not knowing whether any of them had been found by a juvenile python, not knowing whether what he was helping build was the first chapter of a real solution or simply a new kind of problem wearing a different face. Somewhere below in the water and the reed beds, a female python was coiled around a clutch of eggs, regulating their temperature with her own body heat, completely undisturbed, with no awareness of anything approaching. If the mouse drop strategy is eventually scaled and proves effective, she is the animal the entire program is designed to outlast. If it isn't, or if the collateral damage proves too severe to accept, then what Florida has is a crisis with no exit. An invasive species it cannot hunt fast enough, cannot safely poison, and cannot yet reach by any other means. The Everglades has survived a great deal. The question is whether it can survive this, and whether the cure might carry costs that rival the disease itself.